All right, let's dive right in. Today, we are tackling one of the most critical decisions you'll make when you're building an AI app, picking the right embedding model. It's a real balancing act between quality, cost, and of course, speed. This isn't just some catchy phrase, it is the absolute truth. The model you pick to turn your text into numbers, it's going to have a massive impact on your app's performance, how much it costs to run, and how fast it feels. You get it right, and it feels like magic. But if you get it wrong, well, you're in for a world of frustration.
That's the million-dollar question, isn't it? I mean, with dozens and dozens of models out there, the whole landscape can feel, well, pretty chaotic. But don't you worry, we're going to give you a super clear framework to cut through all that noise and make the perfect choice for your project.
Okay, first things first, we gotta bring some order to this chaos. Instead of just staring at a giant, intimidating list of models, we can actually group them into a few distinct categories. And trust me, it makes the whole process way, way easier to manage.
A really great way to think about this is like picking an engine for a car. So, are you building a super efficient commuter car where every penny and every mile per gallon counts? Or maybe you're building a high-performance race car where you only care about raw power and top speed. Or are you building a specialized off-road beast that's designed for one specific rugged terrain? See, the best engine totally depends on the car you're building.
So, here are our three main engine families, so to speak. First up, you've got proprietary APIs from big names like OpenAI or Cohere. These are powerful, they're easy to use, kind of like a top-of-the-line engine that's installed for you. Second, you have the open source models. These are free to use, but you're the mechanic. You got to do the installation and the maintenance yourself. And third, you've got the domain-specific models. These are the highly tuned, specialized engines built for one thing and one thing only, like legal documents or medical data.
And here's the thing, no matter which family you're looking at, every single choice you make boils down to this balancing act. It's always a trade-off between these three things: the quality of your results, the cost to get them, and the speed at which you can do it.
This right here, this is your first big fork in the road. Do you go with a paid API, or do you self-host an open source model? Look, APIs are simple, they're high quality, but you pay for every single use, and you're dependent on another company's servers. Self-hosting, on the other hand, is free to use and gives you total data privacy, but now you're on the hook for server costs and all the maintenance headaches.
All right, now that we have our framework in place, let's meet some of the champions from each category. We're not going to cover every single model out there, that would take forever, but we're going to focus on the key players that really represent the best of what each approach has to offer.
Okay, this table gives us a fantastic snapshot of the whole landscape, using the MTEB benchmark to measure quality. Now, notice how OpenAI's top model, their 3 large, scores around 64%. Pretty impressive. But look right below it. BGE large, an open source model, is right there with it at 63%, but it's free to use. And then you've got a lightweight model like Mini LM, also free, but you can see there's a noticeable drop in quality. This, right here, is the trade-off in action.
So if you've got the budget and you just want the easy button for top-tier quality, the API champions are for you. OpenAI's 3 large is pretty much the king of the hill right now for all-around performance. And for very specific tasks like retrieval augmented generation, or RAG, Voyage AI is an absolute beast, especially with its massive context window.
But what if you want that top tier, best-in-class performance without the API bill? Well, that's where these open-source powerhouses come in. Models like BGE Large and E5 Large are just incredible. They go head-to-head with the best proprietary APIs on quality, but you run them on your own servers, giving you complete control.
And then we have the efficient workhorse. I'm talking about all Mini LM. This model is the go-to for so many developers. Why? Because it's free, it's blazing fast, and it's small enough to run on your laptop. It is the perfect choice for prototyping, for projects where every penny counts, or really any time you just need to get up and running quickly.
Okay, so far, we've pretty much been talking about general-purpose models, and they're great for things like web pages or just general documents. But what happens when your data is weird? What if you're working with legal contracts or medical research papers or tons of source code?
And bam, this chart says it all. Using a model that's been specifically pre-trained on your type of data gives you a massive performance boost. This chart shows LegalBert just crushing a general model on legal text by 20 to 30%. That is not a small improvement, people. That is a total game changer. And the same thing applies to models for medicine, science, or code.
Okay, we have met the players. Now let's put all this knowledge into action.
how do you actually make a decision? Don't worry, here's a simple, practical framework that's going to guide you right to the perfect choice. Honestly, it really just comes down to these 3 steps. First, figure out your budget. Are you willing to pay for an API, or do you need to self-host? Second, what level of quality do you actually need? Are you building a quick demo or a state-of-the-art production system? And third, take a hard look at your data. Is it general stuff, or is it highly specialized?
And just to make that budget decision a little more real, take a look at this scenario. Let's say you need to embed 1 million documents and then run 100,000 queries a month. With OpenAI's older ADA model, that's about $100 up front and $10 a month. Their newer, cheaper DALL-E 3 small model, just $20 up front and $2 a month. And self-hosting is free for the model itself, but you're probably going to pay somewhere between $50 and $200 a month for the server to run it.
What this really shows is how fast innovation is driving down costs. I mean, to put a number on it, OpenAI's new Text Embedding 3 Small isn't just a little cheaper than its very popular predecessor. It is 5 times cheaper. That completely changes the calculation for a lot of apps.
But choosing a model isn't just about what you need today. We have to talk about the long game. What happens 6 months from now when a brand new, better model comes out? This is a crucial consideration that's so easy to overlook at the beginning.
This right here is the single most important rule to understand. The vectors, the numbers created by one model are completely incompatible with the vectors from another. It's like they live in different mathematical universes. So this means you can't just hot swap your model like you're changing a tire. It doesn't work that way.
So what does it actually take if you decide to switch? Well, you have to follow this playbook. You have to re-embed every single one of your documents with the new model, then you have to update your entire vector database, and then you have to test everything from scratch. As you can probably guess, it's a pretty significant engineering project.
This is a classic, textbook example of what engineers call technical debt. Choosing a model that's easy and cheap for your prototype today might feel like a quick win, but it could lock you into a massive, expensive migration project down the road when you need to scale up to higher quality. Thinking about this stuff up front can save you a huge headache later.
So, let's bring it all together. What should you take away from this? First, always start by defining your budget and quality needs. For quick prototypes, all Mini-LM is your absolute best friend. For a cost-effective way to get into production, OpenAI's 3 Small is a fantastic option. If you have specialized data, a domain-specific model is pretty much a must. And most importantly, and I can't stress this enough, benchmarks are a guide, but you have to test on your own data.
At the end of the day, your choice of an embedding model is a bet. It's a bet on the future of your project. It's a foundational architectural decision. So you have to ask yourself, are you just building a quick prototype scooter to get around the block? Or are you engineering a production race car built to perform and scale for the long haul? The answer to that question, well, it will guide you to the perfect engine for the job. Thanks for tuning in.